Hey everyone, and welcome back to the channel. Before we begin here with this problem, please make sure that you like and subscribe because it really does help out our channel, and it also really helps us reach others in need of assistance with these particular topics. So what we're going to be talking about today is trigonometry, and we're going to be finding the trig functions of sine, cosine, and tangent for this right triangle shown on the screen here. Now, keep in mind, we are not going to be finding what that actual angle theta is. We are just going to be finding what the sine, the cosine, and the tangent of that angle is equal to regarding the sides of the triangle. In later videos, we will actually be determining what that angle really is, the actual degrees and measurement of that angle. So let's go ahead and let's begin here. So if we are looking for the sine, the cosine, and the tangent of an angle, we have to know a few things about this triangle. For the angle, which is theta, we need to know what the adjacent side is, which the adjacent side we are just going to label as A. We have to know what the opposite side is, which we are just going to label as O. And we also have to know the side of the hypotenuse, or the length of the hypotenuse, which that is how you spell hypotenuse, I think. Other ways, we're just going to write that as capital H. So looking at this angle here, with regards where the angle is placed right here in this bottom left-hand corner, adjacent means the side that makes up the right angle that is right next to that theta angle that you're looking for. So this is our right angle, and this is the leg of the right triangle that makes up this right triangle, because there are two, this vertical one of 3 and this one of 4. But the 4 is the adjacent one because that's where the angle is being measured at. So for this particular triangle, our adjacent side is 4. The opposite side is the opposite leg that the angle is not touching. So the angle is being measured from the hypotenuse to this 4 leg, the adjacent side. The opposite is the exact opposite side of that angle furthest away from it. And that would be 3 in this case. And then the hypotenuse is the longest side, which will always be attached to the angle, and you're looking at right triangles. So the hypotenuse side is this one labeled here, and you can find that using the Pythagorean theorem. So the Pythagorean theorem is essentially where you would have your hypotenuse side of c squared is equal to a squared plus b squared, where you would have a being this side or b being this side. So let's just rearrange this and substitute in our variables of a, o, and h. So we would have our hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. So essentially what we have going on here, we want to find our hypotenuse side. We would have the square root of our adjacent side squared plus our opposite side squared. Sorry, that square root did not need to be that long. So just filling in what we have. So we have our adjacent side, which is 4 squared, plus our opposite side, which is 3 squared. So this gives us the square root of 25, because this is 16 plus 9, and that would actually give us 5. So our hypotenuse side is 5, which is this right here. Okay, so now that we have the adjacent side marked, the opposite side marked, and the hypotenuse side marked, which this is our adjacent and our opposite, we can actually start finding out and start writing out what the sine of the angle is, cosine angle, and tangent is. So let's go ahead and start writing these trig functions out here. So the sine of the angle theta is going to be equal to the opposite side over the hypotenuse. Our cosine of our angle theta is going to be equal to the adjacent side over the hypotenuse. And then lastly, our tangent of our angle theta is going to be equal to the opposite side over the adjacent side. So a good acronym to use to remember this would be SOH-CAH-TOA. SOH-CAH-TOA. So the SOH-CAH-TOA will be the sine, which is equal to the opposite over the hypotenuse. The COA part will be cosine is equal to adjacent over hypotenuse. And lastly, the TOA is the tangent is equal to the opposite over adjacent. So this is a fantastic acronym to memorize for trig functions of right angle or right triangles. So let's actually fill these in now with the numbers that we have. So scrolling down here a bit, or actually I can squeeze them in right here. Let's just change our coloring real quick to blue. So for the sine of the angle, we will have our opposite over our hypotenuse, which is 3/5. So 3/5. And then the cosine is the adjacent over the hypotenuse, which is 4/5. And then the tangent, which is the opposite over the adjacent, which is 3/4. And what's shown in blue is your answers for what is the sine of theta, the cosine of theta, and the tangent of theta for the right triangle. So the sine of theta is 3/5 for this triangle. The cosine of theta is 4/5 for this triangle. And the tangent of theta is 3/4. As I said, we are not solving for the actual angle in degrees. This is just showing you what this trig function is equal to. So the trig function of tangent theta is equal to 3/4. Now, in later videos, we will actually determine what these angles are, which they all should be the same because it's the same angle. Multiple ways to solve for it there. But for right now, we're just getting the basic background of what the entire trig function is equal to for sine of the angle, the cosine of the angle, and the tangent of the angle. So I hope this video was helpful in explaining these introductory trig topics here. And if you want to see more problems of this variety, as I said, we're going to be continuously uploading videos, and please check out other videos on our channel. If you haven't done so already, please leave this video a like and subscribe to our channel. Thank you for watching, and I hope you have a fantastic day.